Right. Quick announcement from our technology and computing club, technology and innovation club.
Yeah.
Yeah, that's what it is.
Yeah. Yes. Okay. Did you get the email I sent you with the activities on it?
No. Well, I did. Okay. There. Okay. There. All right. Is this good enough?
Yep, that's great.
Okay.
All right. Hi, my name's Ariana. I'm the president of the Technology and Innovation Club, and I'm going to try and convince you guys to come and join this year. So try to do like a little bit of revamping this year, trying to get some more activities. And so basically, whenever there's like a club meeting or anything like that, and then people show up and then, we ask the common question like, oh, what do you guys want to do? No one answers. So I did the liberty of creating a list for inspiration or ideas. So we can go about this a couple of different ways. We could go about this in the way of doing fun activities, like things just for fun, or we could go about it in the way of doing things to boost up your resume. So we have a few options here. Those are just a couple of ideas that I've come up with. If any of them specifically might pique your interest. Just quick question here. How many of you guys are either a freshman or sophomore? Okay. How many of you guys have like any internships or anything like that? Okay, okay.
Right.
So, a good way to be able to go ahead and just like add things to your resume, because when you do apply for internships, you at least want something to be appealing to get your first one. In fact, I'm pretty sure that people who already have had an internship in the past are more likely to get another one. So you kind of want to try and boost your odds in that way. So by joining this club, we could do a couple of activities that could make it so that you actually have something that you can put onto your resume that would make it stand out and show that you are taking that initiative to try and gain more experience. So a couple ideas.
Just quick information. Every computer major has to do an internship in order to graduate.
This is true. This is true. So I mean, a couple of things. So one of the things that I'm planning on doing alone is like I'm planning on doing a volunteer project for animal allies, basically with like a small group of people to be able to do like data analysis and stuff. So that's like a project that I'm doing like on the side to try and like boost up my resume. We could do something of similar nature in the club. We can come together, we can pick a nonprofit organization and we can decide to do some sort of project, whether that's web design oriented, IT, data analysis, chatbot integration, anything of that nature, whatever aligns with people's interests the most. Or we could also just do a self-service project as well, things that just people are interested in general, to try and go ahead and boost that up. Or we can just do fun activities as well. So a couple of things, like we can do like fun games. There can be food, there can be prizes every now and then as well. So just things that like have a good time and try and like relax a bit. So I mean, for a couple of examples, we could do like an ASCII art competition. We can do like mini hackathons. Can also do like things like show and tell. So if people are working on projects and they want to share, or if you guys wanted to come and see some of the upperclassmen's projects for inspiration on what to do on your own, that's something that we could do. One idea that came up was like tours of companies. So if there's like a company that everyone's interested in particular, we could possibly reach out and contact them. So just from like a quick show of hands, how many people would be interested in more of like the fun aspect of the club? Okay, how many people would be interested in more of like the resume-based aspect of the club? Tough crowd, they don't like it.
Yeah, I don't like it at all.
They don't like it. Okay. How many of you guys would be interested in going to the club at all? Wow, guys, that hurts. That hurts. Ow. Okay. Are there any reasons as to why you wouldn't want to go to the club? Like in particular, any reasons that like stand out? Is it because of like an availability thing? Is it like time thing? Or is it just, do my ideas suck? Anything at all? Ouch, guys. Ouch. John, what are you gonna do?
They're a tough crowd, I guess. Here, we can call them by name. How about that? Would that be good? So, okay, we won't call you by name right away if you answer the question. So, are you in other clubs? You're in the part of the club. Okay, other clubs? Right, other clubs? Are you in any other clubs? No. Yes. Uh, yes, okay. Well, give me some reason why you might not participate in the technology club. Okay, that's an excellent reason. Right, okay. It's not your major, right?
That's also fair.
That's fair. All right. Sydney, one reason you haven't been volunteering, we're gonna pick on you. So
Yeah, well, yeah.
is she gonna come? Are you gonna talk to her? Okay, that's good. Never mind. You don't have to tell us. We got you. Emmanuel's working on it. We're recruiting right here on the spot. So
I think that you guys should do more like the activities that you guys did last year, where you guys did like 3D printing.
Yeah, scrolling down, that's actually one of the things there. 3D printing was definitely one of the most popular ones.
Yeah,
So like
3D printing and like how you guys had snacks there and just like very chill. The VR one was very fun. I brought a bunch of friends over. And it was just really fun.
for sure.
But like just like more interactive and more like, this is gonna sound like really selfish, but like more like that give back to the person. But like you know how like our club has like make your own craft, bring back to your room. You have something to remember that club by.
Yeah.
And like this club, like 3D printing was fun. The VR was fun because like you laugh with your friends as you're wearing a big bonky headset, trying not to fall over.
right.
But like just like more stuff like that, or like I don't know. Honestly, I think we should do like the tour one. You guys just like tour, really just like tour some sort of like tech company or something.
Okay. Yeah. Okay.
Like, you know,
Sounds good.
Okay,
Perfect.
sounds good.
Mhm.
One more comment from someone? What would you want to tell Ariana? All right, Dylan or David, one of you guys speak up back there, hiding in the corner. So. Are you in any clubs? No.
You want to recruit them too?
Yes, right. Well, we'll work on them. Okay, we'll work on them. We'll work on you. Okay, so there's a. So maybe like the VR where you're all just you go there and you wear your headsets. Maybe that's why that's so popular. I can see that. Yes. Okay. Sounds good. So okay.
Something else you want
So, yeah, so in the survey, actually, there's a time where I'm asking different questions, like what activities would you be interested in? If none of them are included, to list them, and then also like what day of the week you'd like, and like what kind of time. We're probably gonna shoot more for evenings. Last year was Thursday, but we're probably gonna go off of like a general like popular vote. From what I was asking with the upperclassmen, it looked like Tuesday was the popular vote, but if you guys answered the survey and wanted to come too, that could also change that as well.
Okay, and the survey is posted to the announce list now. So click there, do the survey.
Pretty please.
Okay, even if you don't want to go, you can still indicate your reasons why. Right?
Yes.
Okay, thank you.
Okay, thank you.
Okay. All right. Let's get started here. Oh, it's still really bright in here. Okay. Today we're going to start talking about while loops, first or loops. If you remember, there are three main structures in programming. There's just the sequential structure, and that's the default. Things go line after line. There's what's often called a branch structure. or a decision. And again, the if statement or if else is a good example of that, where your code is going, and at some point you ask some question, if X is greater than 4, whatever, you do this or you do that. So you don't go and do every line of code. At some point you have a decision to make for that. I always think of, like, when you're reading a book, most books you just start at the beginning, read the whole way through, but there's some books where you can choose your own adventure sort of books you read, and at some point they give you some question, and then you either go to this page or this page. That's kind of our branch or decision, which is our if-then statement. Now we're getting to the last part of this, and again, this is all computer language are basically made of these 3 parts. The last thing is a loop, and we'll be looking at loops today. And again, that's where we're going to do some part of it over and over again for that. So I'm going to go into Unit 5, go into the learning materials, and talk about that a little bit. I think I'm going to start with the CS Awesome one here and bring that up. I'm also going to run NetBeans here so we can run some of this code. Share my screen also. So let's just try some of these statements here. We've learned what the if-then statement is. We say if some condition then. So let's just try that out and make sure we remember what that is doing. So let's say we have some variable X equal to some value. And then we can say, like, if X is less than some value, like 100, then we're going to maybe print something out. So again, what is this going to print out? If we say X is equal to 34 and we say if X is less than 100, then print out hello. Here, what is this going to actually print out? Is it going to print out hello? Is it going to print out hello once, a bunch of times? What is it going to do here? So it should, I think, just print out hello once. Because again, we go do this line, X equals 34. We check this, if X is less than 100. If it's true, and it is, then we do this line, right? So when we run this, it's just going to print out hello once for us. So that's the basic if statement we're familiar with. But what if we switch this, instead of an if, we could say while, and then we say while some condition, and then we have our statement. So we're basically changing the if to a while. What is that going to do? If I just type in change the width of the if to a while, what will that do here for this? And so if I run this, what do you think it's going to do? If I say X is equal to 34 while X is less than 100, print out hello. Is it going to print out hello? Will it print out hello once? Will it print out hello more than once? How many times will it print out hello? So I'm going to run this, and it's going to start printing out hello, and it's going to print out hello for a long time. I'm going to have to hit stop here just to see. So how many hellos did it print? It printed out a lot of hellos here. Whoops. So the while is not a if where we branch, it is a loop. So what we do is we check if this is true, then we do this statement. And then when we get here, we loop back up and do our while again. We check if that statement is true, and if it is, we do it again. So we keep repeating this again and again and again until this is it isn't true anymore. As long as this is true, we'll keep going. And so like this will run, this is what we call an infinite loop here. It'll just run for, it'll print out hello. It's a very friendly computer. It is just going to keep printing out hello forever there. Thousands and thousands of hellos here. So usually within a loop, if we don't want it to loop forever, we've got to do something in the loop to change things. So like maybe I would add 1 to X each time. And if I do something like that, it's going to do hellos, but it's going to be some maximum number of hellos. I don't know, what, 70 hellos, something like that. It's going to print out a whole bunch of hellos, but eventually it's going to stop. And that's generally what we want to be doing with loops. We want to keep doing something again and again until we stop somewhere. So if you remember back when we did, if you did CS principles, we had a while loop there in the blocks. And if you're in CS principles, you may start seeing that, but there's a while block in there for that. There's different ways of doing this sort of stuff. So here's kind of the idea of this. We check our condition. If it's true, we do whatever inside the loop, and then we loop back up and check our condition again. And we keep doing this until this condition is false. So over here, we will check if X is less than 100. And if it is, we'll do the loop, the body of the loop. We'll add 1 to X, print it out. And we'll keep doing this. We keep looping this out again and again until it becomes false. And then we exit here. So now often we'll talk about a loop and we'll talk about how to set up a loop. We'll do some initialization before we get to the loop. Like here, I set X equal to 34. We have the loop test where we're testing some condition, like here, if count is less than 10 here. So again, we're checking here if X is less than 100. But then inside the loop, we have to do something that changes the condition of the loop here. In this case, we're adding 1 to the count. I'm doing the same thing here, basically. So we have to do something. So all of our loops will generally have some initialization. We'll have our test criteria, and then we'll change the loop for this. So here's an example, and I'm just going to take this example. I can just run this right here. What will this run? I'm going to say int count equals 1, while count is less than 5. And then we're going to so system.outprint count, and then hit count plus plus, adds 1 to count each time. And again, this is my loop. So I can kind of walk myself through this here. You don't have to do this all the time, but again, in my brain, I'm kind of visualizing this stuff. So we're going to say right up here, count equals 1. So we declare some variable count. It's got a whole different values there. And we're going to stick 1 in there. So it's going to be 1 to start with. And then we're going to ask while count is less than 5. So is that true? Is 1 less than 5? Yes, that's true. So then we go into the loop. We're going to print out count, and then we're going to add 1 to count. So 1 plus 1 is 2. Count is now 2. And then we go back up. That's what these brackets are. We go back up and check count again. Is count less than 5? 2 less than 5? That is true. So then we're going to go in and do the loop. Print this out. So again, we printed off 1. Now we're going to print off 2. And then count equals count plus 1. So it was 2, add 1 to that, that gets it to 3. Go back up here, check if count is less than 5. Is 3 less than 5? True. So as long as it's true, we keep doing the loop. Print this out. So we're printing out 3. We're adding 1 to count. 3 plus 1 is 4. We loop back up. Is 4 less than 5 or less than equal to 5? Yes, 4. Yeah, that is true. So again, we're going to print out count. We're going to print out 4. Add 1 to count. So 4 becomes a 5. Okay, now this is where it starts getting interesting. Is count less than equal to 5? 5 less than or equal to 5? That's still true. So we're going to keep going. So we're going to print out 5. So we are going to print out 5. We're going to add 1 to count. So count is now 6. 5 plus 1 is 6. Okay, so now count is 6. So now we go back up here. While count is less than or equal to 5. Is 6 less than or equal to 5? No. So it's not true anymore. So now we're going to skip over the whole loop and then end the loop. So we're going to go to whatever's after the loop here. And in this case, it's just the end of our program. So our program just prints out 1, 2, 3, 4, 5. Here. So that's what you have to kind of get used to, is these loops repeating again and again and following through with them. Okay, I'm going to jump into the Think Java one. Again, they do a similar stuff. Int n equals 3, while n is less than or is greater than 0, print n. And here they're going to subtract 1. N equals n minus 1. So we're actually going to count down. Here it's going to print off 3, subtract 1 from n. It'll be 2 now. We'll check 2 is still greater than 0. It's going to print off 2. Subtract 1, so n will now be 1 here. And 1 is still greater than 0. So it's going to print off 1. And then now this is going to be 0 here. And now this is no longer true. 0 is not greater than 0. So it's false. So then we drop down here and we'll print off blast off. So this goes 3, 2, 1. Notice it does end gets to be 0 at some point, but not when we print it off here. So we don't do it. Now, if we were to switch these around, it would be a little different. Let me take that and put it over here. If I run this, it's 3, 2, 1 blast off. But again, if I switch this around a little bit, if I put this statement up above here, that's a slightly different thing. We subtract and then we print it out. So that's not going to go 3, 2, 1 blast off. That's going to go 2, 1, 0 blast off here. So again, depending on how you structure your if, you can get different behavior for that. And again, similar if we do less than or equals and stuff like that, and where we start. So how would we set this up if we wanted to go start to 10, go to 0, and then say blast off? So if I did this as 10, would that work? So that's going to go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0 blast off. But it's not going to do 10. It's actually because right away we subtract 1. I'm going to try 11 and then do that. That would go 10, 9, 8, all the way down to 0, including 0 and print blast off for that. And again, here's our thing. We have some check that's a Boolean condition. If it's true, we do our statements and loop back up and check again with this. So. Now, with while loops, we almost always will do some sort of change. We do a lot of these increments and decrements where we're adding 1 to it each time through. We'll talk about these, what we often call counter control loops. We have some variable, a counter. We set it equal to some value. We check if it's above or below some value, and then we increment it or decrement it inside our value. And again, this talks about this plus plus being the same thing as this I equals I plus 1 or I plus plus doing the same thing. Okay, let's try one more. So we've been looking at the while statement. I'm going to show you another statement, a do while statement. And in this case, we say do, and then we do our statement, and then we say while, and then some Boolean expression. What this guarantees is that we always are going to do our statement once, at least. And then we are going to check our expression and see if we should do it some more. So if you have a loop where you always want to go through the loop at least once, and then decide at the bottom after that, if you want to do it again, that's a do while. I learned an old language, and we called this a repeat until loop. Repeat this statement until this is true there. In Java, it's called a do while. Do these statements while some Boolean expression is true for this. So we can keep asking and stuff. I actually think we will use the do while statement more than just the while statement here. Because the while statement, you might, if this Boolean expression is not true, you might never do the statement. So again, if you want to do something maybe 0 times, but maybe more, then you can do, then a while loop is what you want. If you're always going to want to do some statement once or more, then you should do the do while. So, okay. Now there's other loops, controls, breaks, or continues. We are not going to allow you to use breaks or continues there. In our stuff, and the stuff you're doing, it's just poor programming to use breaks and continues. Breaks will get you out of a loop, and break out of a loop or continue jump to the thing. You should never have to, well, in this class, you will never have to use breaks or continues. You can always write your loop properly without them. So, okay, let's look at an example here. I'm going to just total up a bunch of numbers here, and I'm going to do it in a couple different ways here. So I'm going to do this example. I'm going to create a new example over here. I'm going to call it Unit 5 sums for this. I'm going to create that. Okay. Let's try this one. I'm going to do this main here. And this is a version that doesn't have a loop. So it should seem very familiar to us. So we're going to ask the user to enter 5 numbers. So again, we have a scanner. We're going to ask, just say, we're going to total up 5 integers. I'm going to say enter the first number and then use our scanner, next int, and store that in the number 1 and add that to our sum. And then we're going to ask it to enter the second number, input that in the num2 and add that to our sum. Add a third number, a fourth number, and a fifth number. So each time through, we're adding each number to our sum here, and then we're printing out our sum. So when we run this, it just adds us, oops. I'm missing my import there. Okay, now it should be happy. So it'll ask me to enter a number, 45, enter another number, 32. I was just in my office before this class, totaling up some expenses for my expense report. I hate expense reports. But I had to total up numbers with, I open up a little calculator. So this is like, basically could be doing my expense report there. But what if this one always does 5 numbers? What if I only want to quit at this point? This would not let me do this. It requires me to do 5 numbers and then print off the total for these 5 numbers. So while this works, it's not very flexible here. So we're going to look at a version of this with a do-while loop. Here's our do-while loop. Let's see if we can understand that. So again, we declare our scanner. We declare our sum here. We're going to say, we're going to total up numbers until you enter 0. And then we start our loop, do, and we have a parenthesis. And then here's our loop. And we're going to do this while the number is not 0. So we're going to ask the user enter a number. We're going to do input.nextInt, store that in number, and add that to our sum. And then we're going to keep doing that till they enter 0. So now if I run this, I can enter a number like 5 and 4, and then I'm done. I can just hit 0, and I'll say the total of those numbers is 9 for that. So it adds up those numbers. Now, if I had a bunch of numbers, I could do more. I could do 6 and 34 and 54 and 3 and 8. And you keep adding numbers as long as I want. It'll loop forever until I enter 0. And then I'll print off the total of all the numbers. So you kind of see how this do loop works. We say do, and then we begin. We print off enter a number. We read that in, add it to our sum, and do this while the number is not 0. We always are going to have the user enter at least one number. Even if they want to quit right away and enter 0, we still are going to have them enter a number. Even if they hit 0 right away, that's still one time we ask. So we are doing this one or more times, and that's what the do loop is very good for. You're always going to want to do this one or more times here. And then at the end, we just print off the sum. Does that loop make sense? If I can make it a little bigger. You're beginning to kind of understand how do loops might work. So let's look at alternatives. Now, I said this was a do while, and there's also just a while loop. So a do while, we say do and then our loop, and then we have our condition at the end. So that means we always do go through our loop statements once and then check our condition. Now let's do this with a while loop. So it's going to be the same statement here. Again, we're going to set sum equals 0, enter numbers, enter 0. And again, we're going to do our while loop while number is not equal to 0. And then so we're going to add it to the sum, say enter the next number and read that in. But we're going to check this right away. So we've got to have a number before we even can start this loop. So we ask them above, remember I often say you do some setup before your loop. So in this case, one of the things we're setting up is we're reading in the first number. We want to say enter a number and read that in. And then we're going to start a loop. So they've entered the first number. We're checking if that's not 0. If it's not 0, we're going to add that number to our sum, print off, enter another number, and read in the next number. And then we can do our loop here forever. So again, one of the interesting things is that while loops and do while loops are basically, you can do the same thing with them, with the right statements, right setups, and any while loop you can translate into a do while loop with an if statement or vice versa there. You don't actually need both of them, and some languages don't provide both there, but it is handy. Do you want to check your condition at the start of the loop or at the end of the loop? And so again, while we did this in a while loop, I think it's much better as a do while loop. It's shorter because we don't have to do this big setup here before we even start our loop. So I'm going to switch back. I like the do while loop here. Oops, not that far back. I like this one where we just say we're going to total up the numbers, do while loop. So here's a question. Why do we have them wait till we want to enter 0? Can we do another number? Maybe like, let's say we have a special secret number like 999. You have to enter 999 to end the loop. Could we just switch this? So will this work the same if we just say, okay, we're going to say we'll total numbers until you enter 999. Okay, and then while number does not equal 999, we're going to keep going. We're going to do this loop. Right? That should work just fine. Why doesn't it work? So I'm going to enter a number. I'm going to hit 4. I'm going to hit 3. Now I'm going to hit 999. It tells me 4 plus 3 is 1,006 because it added the 999 in there, right? So the way this was set up is that when we read the next number in, where we enter the number, so again, we ask them to enter a number, we read that number in, we say enter a number, we read that in the number, and we always add it to the sum. And then we check if it's the whatever we're using as the end here. And then if it's that, we've already added it to the sum here. So that's generally not what we want to do for this stuff. So we have to kind of watch this stuff and how this works. So we probably don't want to do it this way. Now, there's ways of doing it this way by just moving some of the code around, but we've got to kind of be careful how we set up these loops to do what we want. Another interesting thing here is we declare a number up here, but we don't use it. Usually we don't, why can't we just say int number here and not have it up there? You know, isn't that a nice shortcut where you say int number equals input that next line? We do that, we've done that before, right? So that should work. But now if I try to run this, I get an error here. Here, runtime exception, compile code cannot find symbol. It's trying to figure out what number is, and it can't. So one thing we haven't talked about is something called the scope, or the neighborhood where our variable lives. Basically, a variable lives within the braces where it's defined. That's its scope. So if we say int number here, and it's inside these braces, number's only good inside those braces here, because that's where we declared it. And by declare, say, when we first use it and we say what type it is so that the computer can set up the memory location, the right size. Oh, it's going to be an integer. I need enough space to store an integer. Is it a long integer or short? And what is it called? It's called number. So this part, wherever that is, that's that scope or neighborhood. So the while part is outside that scope. So this number doesn't know what it is. So that's why we have to declare the variable up here or somewhere else. And then we just want to use it here. So again, with loops and loop counters, we generally want to declare our variables above our loop and anything else we're going to use in our loop. So we're going to want to do some setup. And then we'll just use the variable. We won't redeclare it. We've already told the computer what type it is there. And then, because now when we do this, the scope of this number, let me zoom out a little bit. The scope of this number is anywhere in this brace. That's the neighborhood it lives in, is from there to there in blue. Because number is defined in that. So basically variables can't kind of escape or can't get out or be referenced outside of their scope or their braces for this. All right. If we have this and we wanted to print off the average, right now we printed off the total. What if we want to print off the average? What would we have to do? So here. So if we want to print off the average too, also, we have the sum. So the average is, so like if I were to run this here and enter 4 numbers, I could say this, the sum divided by 4 should be the average, right? So this would work if I entered 4 numbers. So 6 and 7 and 6 and 8 and 0. Total is 27 and average is 6.75 of those. Okay. But this only works if I have 4 numbers. If I have less than that, this isn't going to work. So to do the average, I need to count my variables for this. So I don't have a count here of my variables. So I can add, I have a sum, I can add another variable for my count. I'm going to just make it an int count. I'm going to start at 0. And then every time through, whenever I read in a number, I'm going to add 1 to the count. Count equals count plus 1. Add 1. I'm getting kind of tired of writing this count equals count plus 1. I'm going to use this shortcut of plus equals. That just seems that's kind of long. I'm just going to go with this plus plus. Okay, count plus plus will add 1 to count. I'm just going to use that shorthand here. So now that'll add 1 to count, and then here I can take the sum divided by the count to calculate the average. So I do have to watch. This is 2 integers by each other, so that integer is going to be weird. I might make count a double because again, I'm going to divide there. I shouldn't make it an integer, so I'm going to make it a double, and then hopefully that'll be a little better. So I'm going to add 1. So enter a number 6, 7, 0. Total is 13. Average is 4.3. What's the average of 6 and 7? Shouldn't that be 6.5? If I have 6 and I have 7, I want to average 6 and 7. Shouldn't that be 6.5? Why is it telling me it's 4.3? So I'm not counting correctly here. I'm counting every number, and then again, I'm getting my 0. I'm counting my 0 here for this one. I think. So I'm counting 1, 2, 3 here. So I'm taking my sum, divide by count, and count will be 3 when I get through this. So I have to watch how I'm doing my count and set things up correctly here. You have a couple options. Since I'm counting it 1 extra time, I could subtract 1 at the end here. I could, so I could do count equals count minus 1 or count minus minus here. And then if I run it and I do, okay, if I do 6 plus 7 plus and then 0, 6.5, that sounds like a better average. So here's an example, another example I did. I'm trying to remember what we did here. Count equals 0. Here, we actually checked if the number is not 0 that we entered inside our loop, then we add it to the sum and add it to the count here. So we only count, we don't count the 0 here. So that's another way of doing it. Is put that inside our loop. There are some other ones here. Let's just look at this last one. I'm going to do the counter control loop. We are going to talk about counter control loops a lot in the next couple of weeks because this is what we do a lot. It's probably the most common loops. In fact, there'll be a new type of loop called a for loop that'll be set up just for this type of stuff. So let's look at a counter control loop here and what that does. So rather than having to just enter loops values as much as we want, we can ask ahead of time, how many numbers do you have? Like if you're doing your expense report, how many expenses do you have? And I can say, I have 4 numbers. And they'll ask, enter number 1. And I'll say, that's 34. Enter number 2. I'll enter another one. And I'll enter another one. And I'll enter another one. I entered 4, and then it'll give me a sum. So this is very similar to what we did at the beginning with the fixed one, but now this works for any. I could say enter, I could do 20. I have 22 numbers and just start entering numbers, and it will start adding up all these numbers here. Until I'm done. So it can work for any numbers. Now, how does this work? I haven't asked the user how many numbers are entered. I read in my count. So I have a variable called count. And then I say while some I is less than the count here, do things. I'm going gonna rename, I don't think count is the best value here. I'm gonna call this max numbers. So I'm gonna read in the maximum number of numbers, and then while I is less than 0, I is my thing I'm gonna count each time. I'm gonna say while I is less than max numbers, and then I'm gonna print off, enter the number, read that in, add it to my sum, and do this loop here. So again, we have, and we'll see this some more, we'll have some initialization of our counter, we'll have our check inside our loop, and then we'll have some increment or decrement that we'll want to do so that we do this. So this will always work if we say I have 4 numbers or 10 numbers, I'll always do it 4 times or 10 times with this counter controlled value here. We'll do more of those in the next couple weeks, like I say. Let's look at some different versions of this. I don't like, how we're always asking, like to have this, what I call a magic number, 0 or 999 to continue. So what if we just ask the user every time if they have more numbers? So this version, we run this to enter a number. I'm going to enter 55. Says, do you have more numbers? Yes, no. And I say, yes, I have more numbers. And then I'll enter another number. I said, do you have more numbers? I say no. And then I'll print off the sum. So we can certainly do something like that, where we ask a question each time through, it's a little more typing. So I don't know if it's the best solution. But again, here in our loop, we have our do, we enter a number, add it to our sum, and then we ask, do you have more numbers? And we do our next line, and we read that into a string. So we have a special string variable. Here we're just calling it more. And then we're going to loop while more. And again, when we're at strings, we have to do an equals. More dot equals ignore case to yes. So did they say yes, they have more numbers? If that's true, then you keep looping around. Oh, no, not the best solution. Here's an interesting solution to this problem, I think, where we're going to read, well, so the problem with these, I'm going to go back to this one. What happens if I don't enter a number in here? Here, so it says enter a number. What if I say 5, or I just say hello? If I try to read a number, read in a number, and I enter words, it confuses Java. It crashes Java. It says that's not an integer. You want to say next int, and there isn't a next int. So it's input, I get an exception, input mismatch exception, and we crash. So to avoid this, if we want them to be able to enter words and numbers, we're going to use a string here. So this version. But if we're using a string, you can't add strings up very well, like math. So we're going to have a string to read in that line, input that next line. We're going to check if it's equal to done. If it's done, we're going to quit. If it's not done, then we're going to try to convert that to an integer here, and then we're going to add it. So this is a version of it where you keep entering numbers and they just write done when you're done. So we can enter a number like 44 and 22, and now we're done. We can just hit done and then it'll quit. It gets confused if you enter anything but done. So if I say 44 and I say, I am done, it freaks out because it's not the word done and it's not a number. here. So it has some problems. But you can do things, and there's a lot of ways. Here we're trying to take a string, what they entered, and what we call parse it, convert it to an integer there. You can also check ahead of time if this is a, and this is what you see, like whenever you do an online form, and sometimes I hate these, you'll enter, say enter your age or a number or whatever, or your email address, and it'll check as you're typing, or after you're typing, you go to the next one, it'll say, oh, that, that was supposed to be a number, and it'll highlight it, or it'll bounce you back there, or it'll have a certain format you want to put things in. So we won't do as much checking, but in more advanced classes, we want to do a lot more checking of their input and that it's in the right format there.
Does Java have our to like wanting have to be just like 1, 2, 3?
No, well, this would work fine with negative numbers. I could easily do that. So again, I could be doing like 6 and then a -4. And then I could say done, and that would add those up to that. It would work fine with negative numbers here for this. Now, it all depends on how you have this set up here. But yeah, most of these examples work fine with negative numbers. So, now, Chris has this long math example here where we are going to look at math here and do operators on math for this. I'm just going to show you quickly what this is, but not walk through. He has some nice videos on this, so I'm not going to walk through that. I'm going to put this in my sandbox area, I think. Oops. Okay. So here's the example. This program will ask you to perform several mathematical operators. What numbers would you like to start with? We're going to start with 60. And then it displays this menu, and you want to add 100 to it or subtract 50 or whatever. I'm gonna subtract 50 from it. So it says I have 10 now. What do I want to do? I'm going to multiply that by 2. So I'm going to hit 3 and enter that. And so it's just like kind of you do these operations, and it just shows a menu here. So he walks through this example, and there's these videos that walk through that. That if you want more review, you can go through those. So, okay, we're going to save these class functions for things. On Wednesday, what are we going to do on Wednesday, you ask? Hopefully Tom's not going to talk the whole time on Wednesday. Oh, Wednesday's community day. Okay, what are we going to do on Friday? You're wondering, because you're volunteering somewhere on Wednesday, right? For community day? Right. Just nods and say, yes, I'm volunteering. Good job. Thank you. That makes me feel better. There. Okay. So there's no class on Wednesday because of community day here. And so on Friday, we'll be doing the virtual pet simulation where we'll create a virtual pet with a loop and try that out. There'll be some starting code for that. So we'll do that. And then there's this assignment with these different dice games. You have to pick one of these 3 games. Games might be an exaggeration. They're kind of games. But you have to pick one of these 3 dice activities and do one of them here. So, all right. Sounds good. So Wednesday, you will be volunteering. Friday, we'll do the virtual pets. Sound good? Yes, Tom. Thank you. That was a very good class, Tom. David's coming in with the win. Okay, see you on Friday. Sydney, if you want to come on Wednesday, you can. No one else will be here, but you can. Oh. Kyle. Yeah.
What?